Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and today we'll be talking about question number 14 of Network Interview Preparation Series. Today's question is going to be really interesting as other questions of this series. And now you must be wondering, Mr. Vishnu, don't you say the same thing for all the questions? Yes, I do, because all these questions have been asked in many network interviews, believe me. And today's question is actually my personal favorite. Today's question is, can you design a small office network? And if you can, what is going to be your approach? This question seems to be really simple, but it has many concepts involved. I'm not saying it's hard question, but concepts are many, right? So, if you are with me in this journey, let's talk about the agenda of today's session. Today's session or today's question, we'll be talking about first thing first, our characters. Why characters? Because today I am going to tell you a story of designing a network absolutely from scratch. And if there is a story, we need characters, right? Once done, we'll be talking about requirement collection. Why basically I have written, don't jump into the design, don't worry about it. We will be talking about it. The third thing is we will be talking about high level design. So if you give me your next 1 hour, yes, 1 hour is needed here. This video is going to be long. Why? Because if you need to spend, if you want to learn something absolutely from scratch, you need to spend some time. So if you give me your 1 hour, believe me, this session, this design session is going to be with you forever. So having said that, let's talk about first thing first, our characters. So we have two characters here, right? We have Mr. Rahul, you can see here, and we have Anjali also. If we talk about Rahul, Rahul has experience of approximately 2 years in networking industry, computer networking industry. He understands routing well, he understands switching well, he understands network security also, and his fundamentals are rock solid. He has foundational knowledge, basic knowledge of all these concepts, and he is very good with respect to concept. If we talk about Anjali, Anjali is a bit senior to Mr. Rahul. She is having experience of 4 to 6 years, right? And especially she has experience in the design field. Now, let's go back to our character, Mr. Rahul. Rahul has this very interesting, what we can say, characteristic, right? Whenever you ask Rahul any questions regarding fundamentals, foundations, computer networking concept, he is very good. He answers all of them with, and his confidence is just unmatchable, right? But when you give him a scenario-based question or a design question, he just freeze, right? Again, I'm saying foundation is strong, but he's not able to answer the design or scenario-based question. So he went to ask Anjali, right? Because he needs help. Why he needs help? Because his interview is lined up in upcoming 2 weeks. So he went to Anjali and he's saying, Anjali, can you help me with respect to the interview? Because I just can't answer design based or scenario based question. And Anjali is saying, don't worry, Rahul, I am going to help you. And believe me, the first thing you require in designing any network that you should have the solid concept. And I know you, and you have the solid concepts, right? So the one thing which is absolutely mandatory for designing a network, you already have it. But if you really want to understand the process of designing a network absolutely from scratch, you need to hear my story. So today's session is all about Anjali's story, how she designed her first network. So she's talking about that 3 years back when she was in a particular company, she got a project to design a network, right? And that project was to design a network for a company. The company name was Sports India Private Limited. First thing first, Anjali, when she got this project, she started doing some research about Sports India. What exactly Sports India is, what exactly it does, right? Then she found that Sports India is actually a company which makes sporting goods. What is the meaning of sporting goods? Anything related to sports. For example, if we talk about cricket, this company makes cricket bat, cricket ball, pads, a stump, and so many things. It also makes, right, so many things with respect to badminton, with respect to tennis, you name it, and this company make that product for you, right? So Sports India is into sports, and if you want to order all these stuff, you have to log in into their website and you need to order. This is what Anjali knew, and with that, Anjali has a special message to Rahul that whenever you go or whenever you try to build a network, just try to do a bit of research about the business, right? And the another message Anjali want to give is that whenever you get a project, don't just jump into designing a network. You need to ask questions to customer. You need to collect the requirement, because if the requirements are not clear, you are not clear. You cannot design a network until and unless you have the requirements with you. And that is where Anjali went to Sports India office, right? She met with their professionals, officials, right? And luckily she got a technical guy there and maybe other guys who are at CEO level. So she wanted to discuss that I got a project that you need a small office network. I am the architect. I can build it for you, but I need answers of some questions. And then these Sports India guys are okay with that, right? Generally, if you are a part of company, we call that as an on-site meeting. You go to on-site, you collect the requirement, and then you start designing a network, right? So this piece, requirement collection, is absolutely important, absolutely necessary. So see, try to understand how Anjali is asking the questions and how she is collecting the requirement. First thing first, Anjali said that I got a requirement that you need to build a small office network. Can I know how many guys or how many people we are talking here? So Sports India guys said that basically we are talking about 40 to 50 people here. Anjali is okay. Then Anjali asked, do you have a specific space for it? And Sports India officials said that yes, they have rented a building of 3 floors or maybe 4 floors, right? And all these 40 to 50 people will be sitting maybe one on the first floor, second floor, and third floor. They will occupy all the 3 floors. Anjali is doing okay. At the back of the thing, Anjali is making all these notes because all these things are very, very important while designing the network. And I'll tell you how or why, right? So, third thing Anjali asked that do you have some idea about the devices you are going to have in this company? Because eventually you are not going to connect people, you are going to connect people devices, right? And that is the whole thing. Sports India is saying that yes, every employee is going to have a personal laptop for sure. Some of the employees in the office, they will be having, right, they will be having the personal computers. Some employees come with their iPad or phone and that need to be connected to the network. Then they say that basically there we would like to place printers also, means 3 printers on 3 different floors, right? Once done, we will be having some IP cameras also, okay? Printers, IP cameras, and then few of the servers are also because on one of the server one very important thing is running, right? And customer is always saying again and again about it that on one server, basically they are running the website of Sports India Private Limited, where many people come and order. And this is how Sports India earns money. This website should not be down, right? And whatever Anjali asks, Sports India always say one thing after maybe 5 or 10 sentences. Anjali, you want to build network, you build it, but make sure that this Sports India should always be up and running, right? Anjali have written all these requirements into into her diary, right? We all know about it. Now, Anjali asked another question that all these people are going to be in separate or different departments, and Sport India says that yes, there are three different departments we have. We have HR department, we have sales department, and we have uh, engineering department, right? Why Anjali would have asked this question? If you are from the network background, which you are, right? You need to understand that Anjali is talking about VLANs now or IP addressing also, right? So now what the requirement we have collected till now, we have collected the requirement of that there are 40-50 people, what are the number of devices, there are different departments. Now Anjali is talking about how these devices will be carrying IP address. And these people say, we do not know much about IP addressing. So you need to decide how these guys are going to get the IP addresses, right? And then Anjali said that, is there any requirement of talking with the names of the device in internal network? And these people say, yes, the device should talk each other with the name itself. Now Anjali has written everything down and she now know that there is a need of DHCP and DNS also, right? Again, customer again and again is saying whatever you do, right? Don't let this website down, right? Because this is the most important and the crucial piece for Sports India, right? Then Anjali asked that, do you have any server on-prem? And Sports India said, yes, I have a server where my website is running. Don't let it down, right? But apart from that, right? Whatever the server you are asking about, like email server, or file transfer server, we are using cloud services, and cloud is on internet, so we need internet connectivity all the time. Internet connectivity should never be down. Why? Because Sports India should be up and running on internet, and my email and file transfer is on the cloud, so so internet should be always up and running, right? Try to understand. Anjali has collected various requirements from the customer, right? She is making all, she's writing all these requirements in a piece of paper or maybe in her diary. But when Anjali came, right, she thought that this is a really small network of maybe few people who are sitting inside in a single room. But this is not the case. We are talking about three different floors. We are talking about 40 or 50 people, and we are not going to connect people at the end of the day. We are going to connect these devices. One person can have approximately 2 to 2.5 or maybe 2 to 3 devices, right? So we are talking here about 120 device connection, not only 40 to 50 people, right? Try to understand. If you want to build a network, design a network absolutely from scratch, this thing is very, very important, right? Now, let's talk about one more thing Anjali has asked, that that is fine. This is your requirement of today's setup. But what do you think that how many employees you are going to have in upcoming 2 to 3 years? Because if I am a good designer, I need to cater the requirement which will be there in future also, right? So Sports India official says that basically in upcoming 2 to 3 years, they are seeing these employee numbers can go from 50 to maybe 100, right? So whatever the design, Anjali, you are creating, make sure that it caters the future need also, right? Interesting. So now what Anjali has done, Anjali uh, has created a list of all the business and technical requirements. And Anjali is saying, Mr. Rahul, this is very, very important, really important to collect these requirements. Because once you understand these requirements, then you can start the design process. For example, see what she has written at the first place. She has written website should be always up and running, right? And then this network should suppose minimum 50 to 100 people. There are going to be different departments. We will be talking about the technology. We are not going to explain the technology. Otherwise, this session is going to be 15, 16 hours long because there are many technologies involved. But believe me, if you have done the starting 13 questions, if you have gone through all those concepts, right, this question is going to be really simple for you. Otherwise, I would highly suggest, see all these questions in sequence. Everything is on YouTube, by the way, right? Then Anjali said that basically PC, server, monitor, laptop, camera. What is the monitor? Sports India says that every floor they are going to put monitor also to showcase some important information to employees. Sport India also says there should not be single point of failure. What is the meaning of single point of failure? I will be talking about it, don't worry. The meaning is if one device goes down, right, it doesn't make the whole network down, right? Because if one device, that little piece of device is down, we will be calling that little piece as single point of failure. Of course, they are saying DHCP and DNS is required on-prem. The meaning of on-premise is on-premise, on-premises. Believe me, when you go and talk about customers, they call on-prem or basically cloud. The meaning is that we want DHCP and DNS server to be there, right there in that building itself. And if there is in that building, basically we call it on premises. And of course, the different apps, email, FTP, everything is in cloud. So apps is in cloud, but there are some server which needs to be there on-prem. Internet should always be up. More employees. Maybe Anjali is trying to build a network which can cater the need of 200 people. Why only 100, right? It means that Anjali is thinking about scaling the network also in future. Means in the same network, if we do some changes, it can work with 200 people also, right? Network should come up on its own. If there is a problem, it can heal it, right? There should be an option for work from home. What is the meaning? The meaning is Sports India also said, which we didn't discuss in the previous board, that out of 40 to 50 employees, only 30 employees comes every day and the remaining 20 employees, right, they work from home. It is not the case that those are the same employees, but yes, the regular attendance is only 30 out of 50 and 20 works from home, right? If that is the case, we need to build network for them also, because if they are working from home, they will be connecting over the internet and then they can talk to the people who are in the office. And if you come from the internet is a medium, right, where bad people are also there, right? They can take your data. They can take your Sports India data, right? It's a problem. So we need to build something for work from home, and we need to make sure that network is secure. In future, basically, customer is asking the automation is there. We will be talking about it for sure, right? But now, these are the business and technical requirement which we need to cater, which we need to include in our design, right? Now we have everything, and we will make this as a base to create or to start building or designing our network. Having said that, let's move to the next board where we will be talking about building or designing this network, right? So as you know that Sports India was talking about a building which we have seen here, right? And it is having 4 floors. And this is my parking, right? The first floor, second floor, and third floor are the floors which have been taken on rent by Sports India, right? And people are going to be here from different departments, right? These are the people. So what Anjali is saying that anyhow, I need to connect them. So first thing first, Anjali is thinking that I am going to put some switches here because Anjali is also very good with respect to computer fundamentals. She knows that if the PC is here, she need to connect this PC with a switch. If a monitor is there, we need to connect it with the switch, right? Although I am agreeing with you that if there is a laptop, then laptop needs to be connected to wireless, not through a wire to the switch. But believe me, guys, I will be talking about the wireless, right? Maybe after 3 or 4 boards. But If I talk about a wireless, if I give you a hint, then your laptop, and then there is a device which is known as access point. The wireless thing is only between this laptop and AP, but this AP is actually connected to a switch over this wire, the same Ethernet wire, right? So if you are thinking that wireless network is totally different, no, the traffic of wireless is also, right, going over this Ethernet interfaces or over this Ethernet wires, right? So if you can build the Ethernet network on top of it, you can build wireless very easy, right? So we are talking about first wireless, then we will be discussing about wireless wired, then we will be discussing about wireless later. So first thing first, Anjali has put these three switches, switch 1, switch 2, and switch 3, right, at different floors. And she's thinking that let's begin with the 48 port switch. Why 48? Because to begin with, she has to cater the need of around 120 devices. And if you can see here, 48 into 3, if we see, it is going to be 120 plus 24, around 144 ports we are going to have here, right? And Anjali is calling this layer as access layer. Why? Because these people, these employee, connect to the network or access the network through these three switches. And that's why this layer or the set of the switches are known as access layer. As simple as that. Now, you must be wondering, Mr. Vishnu, why can't we connect these two switches together, these three switches together? We can, but we should not. Why? Suppose if we connect these three switches together like this, means switch 1, switch 2, and switch 3. And suppose switch 1 has a PC, switch 3 has a PC. If switch 3 wants to communicate to switch 1, or maybe this PC 1 wants to communicate to PC 2, and if this switch 2 goes down, it's a problem, right? Switch 3 is already down, so of course I cannot connect to the PC connected to it, and also I cannot connect to the PC which are after switch 2. As simple as that. That's why we don't connect these switches together like this. Otherwise, there is going to be this single point of failure, right? This switch, this PC cannot going to be communicate to this one, right? It's a problem. So why? So what do we do, right? What is the solution of this problem? The solution of this problem is Anjali is introducing one more layer of switch, again a switch, and she will be connecting this to this one, right? Now she is calling this as the distribution layer. So if somebody on floor number 3 wants to communicate to floor number 1, what is going to be the traffic path? It will be coming to switch 1, then from switch 1 to this switch, and then basically the traffic path will be like this. See, when you design a network, you need to understand how your traffic flows. As simple as that. But now you must be wondering, don't you think, Anjali, your design is bad? Rahul is saying, right? Anjali was saying that this was my first design, right? So I thought about it, then I saw that this switch is going to be a problem. Why? Because if this switch fails, nobody can communicate with each other, right? Because there is no link between these switches, switch 1, switch 2, and switch 3. And this, if this switch down, everything is down. And customer has specifically mentioned no single point of failure. We do not want it, right? If that is the case, Anjali said that I am going to include one more switch, right? And I will be connecting every switch to these two switches. For example, this switch will go here and this one more connection goes here. Interesting, right? Now we are talking. Now, basically, if one of the switch goes down, we still can communicate. For example, if this switch goes down, right, the traffic from means if somebody wants to go from floor number 2 to 3, it will be going to here, then here, then here, As simple as that, right? So because this second layer of switch, this layer is actually distributing the traffic from first floor towards second or third or vice versa, right? This layer of switch is known as the distribution layer. As simple as that, right? So eventually your network looks like this. We have access layer switch, right? And we have distribution layer switch. Do not worry about the colors. I will be talking about the colors too. Don't worry about them. But if you see here that we have this building, and mostly many people just see this building as a building, right? But network engineer sees different networking devices in it. We have switches and we have routers, we have firewalls and so many other things. But now your question must be that Anjali, why there are different colors, right? You remember one thing that Sports India said that they have three different departments. They have sales, they have marketing, sorry, they have sales, they have HR, they have engineering. So Anjali has created three different VLANs, right? Very, very interesting. Because we all know that if we have a switch, we can create multiple VLANs. Like VLAN is a actually group of ports. So basically this can be your HR, this can be your engineering, and this can be your sales, right? And that is what I am showcasing with three different colors. And if we have different VLANs, then the link between the switch is going to be trunk, because trunk is something which can carry the traffic of multiple VLANs. And that is why Anjali is saying strong knowledge of foundations, right? Knowledge of networking basics is going to be extremely crucial in designing the network. As simple as that, right? Now, why do we have these strange looking things, right? We all know that when we have different VLANs, we need to have IP addressing of those VLANs also, right? If we talk about IP addressing, maybe I can give this HR a subnet, which is 192.168.10.0/24. Maybe this VLAN name is VLAN number 10, this 10, and third octet is same. Suppose I have given this, right? Now I know that in this VLAN I can have 254 hosts, because first address and the last address is going to be reserved. First address is actually your network number. Last address is the broadcast, and the first IP address we give to the default gateway. Similarly, here the engineering department can be having 192.168.20.0/24, and 20.1 is the gateway, right? Where are we creating all these gateways? We are creating these gateways on distributions, which is why I think I have explained all these things in my switching class, my various courses, right? And that is where I would say, right, having knowledge of all these things is absolutely crucial to design the network, right? So we have created all these gateways on distribution switches. And how to create the gateway? We need the concept of switched virtual interface. We need to create this switched virtual interface for the VLAN, and that SVI is going to be your default gateway for that network. As simple as that, right? So till now, what has Anjali done? Anjali has connected various wire devices to the switches, and then she has a second layer, which is a distribution layer, right? And then she connected them via trunk. And we all know that these are my access ports, these are my trunk ports, and here a spanning tree will be running, because we can see the loop in the network, right? From here to here, or maybe from here to here to here to here, and then coming back. So loop is there in the network, and because we have Cisco switches, this spanning tree protocol will be working on its own, right? Believe me, if you are thinking that some designs are good, some designs are bad, no. A good design is a design which can cover most of the requirements of the customer, right? Suppose if I have created a design in 2020, and if you see that design in 2025, you can say, Vishnu, what a crap design you have built. But I would say, no, my design was good because at that moment it catered all the requirement from the customer. But maybe in 2025, there are some different things which my design is not capable of, but I did a good design. So a good design can be bad after some time, right? Again, if you can design a network with some constraint, because customer can put the constraint of money also, right? He can say, no, I can't buy two distribution switches. Then you have to put one. And then you can say there is going to be single point of failure in your network, right? Till now, what we have done, we have introduced IP addressing, right? Subnetting, we have introduced VLAN, we have introduced spanning tree protocol, we have introduced trunk, we have introduced access switches, distribution switches, also switch virtual interface and default gateway. As simple as that, right? So basically, if you see right now, we are good with respect to our initial design. Now, you all know customer has asked to put some servers also, right? Actually, customer didn't ask. One server he wanted, which is his website server. But we know, right, that if we connect a particular device or particular laptop PC, it is going to need IP address. How and from where we are going to give it IP address? First thing first, I would like to showcase the same diagram, whatever you are seeing here, right? In a more simplistic way. See, I do not want to showcase each and every time this building, right? I would like to showcase only this portion now. But try to understand, try to map this, that there is a building. Inside this building, basically, there is going to be a room where you will be seeing all these switches placed, right? We will be talking about it. Now, let's see. Let's move to the next board. So I have removed the building totally from here. Totally, the building is gone, right? What do we have here? We have three access layer switch. We have two distribution layer switch. We have SVIs configured. We have trunk here, right? A spanning tree is also running to avoid the loop. Now the question is that if somebody comes and connect the PC or the laptop here, this guy should be having IP address but from where? From where we are going to give the IP address to this guy, right? And that is where Anjali is saying, I am going to connect a DHCP server as well as a DNS server to the distribution switch. And somebody is asking, why on distribution switches? Why we can't connect them on access? Maybe the DHCP server can be here. The problem is, one, although there are many reasons, but for completeness sake, I'm giving you one reason, that if we connect the DHCP server on another access switch, we need to go to here, then come back here. Three switches will be involved: one access, one distribution, another access, right? Now, if we talk about, if we talk about, if we place the DHCP server right here in the distribution, then we can go in just two switches, right? We are reducing the hops, only one, and then the other switch is this one. As simple as that. Although there are many other reasons, we can discuss it maybe in some other session, but right now I can give you this logic that basically this DHCP and DNS server should be connected. Why do we need DHCP, right? DHCP provides our computers, IP address, computer, or maybe anything, right? Monitor or whatever is going to printer. And why DNS? Because we can communicate with these two devices with their name, right? And these devices' name will not be in Google server. For example, you must be wondering, Mr. Vishnu, why not these names will be in Google server? Google DNS server 8.8.8.8. 8.8.8 will be having the IP and name of all the internet servers, not your private computers, right? If you want to communicate between these two, then you need to have your own DNS, right? For example, this name is XYZ, this name is ABC. If ABC want to communicate to XYZ, first thing first, XYZ's corresponding IP address should be known, right? And that mapping you are going to give on this DNS server here, right? Your local DNS server. But if this guy wants to communicate to internet, this communication is going to be same. Now, the first thing first, the request will go to the DNS server, your local DNS server, and your local DNS server is not going to have the IP address of google.com. That is why this DNS server will be forwarding it to the Google DNS server or maybe any other DNS server which is available on public, right? We know all these things. By the way, in corporate world, in enterprise network, this DHCP and DNS are known as shared services. Why? Because these shared services are needed by everybody. Any computer which wants to communicate to internet, first thing first, they need to have the IP address. The second thing is if we want to resolve the name to IP, they need to have DNS, and that is why DHCP and DNS is going to be there. And now you must be thinking, Mr. Vishnu, what is going to happen if this switch goes down, right? Don't you think that's a single point of failure? Yes, because DHCP, DNS are connected. That's why the companies are having multiple DHCP servers and DNS. One is connected to one distribution switch, the other is connected to another distribution switch. By the way, some companies call this distribution switch as distro. So don't worry about these naming, right? If they are calling distro switches, it means that the switches which are at distribution layer. As simple as that. So till now, what we have done, we have access switches where we connect the endpoints, or basically your laptops, your computers, your printers, right? The second thing, we have connected servers also. And by the way, you can connect the company's website server also where sportsindia.com is running. Now you must be wondering where is the internet connectivity? Don't worry, we will be talking about internet connectivity also, right? Now, let's move to the next board to talk about, right? We can see this thing, all this thing here, but how can we visualize it? Where exactly these devices are placed in that big building? So I am again moving back to that building, right? But before that, right? I just want to showcase the complete diagram with actually your servers. Right, so we have distribution switches here, we have access layer here, we have the servers here. Maybe this is my DNS server, this is my DHCP server. I am just showcasing you two. I just want to showcase here that we need, right, where to connect these shared services. Right now, if we talk about where exactly all these devices are, right, in that big building. So basically, we have this picture. And we see this picture all the time. We don't see the wires here and there, right? But believe me, in this three-floor building, we must be having one room where we have placed these access switches, sorry, these distribution switches and these access switches. So these two switches, two types of switches are right there. And these servers, which I have connected with distros, are also in some room, and we call that room as network room. This is my definition, right? But I think in network industry, basically we call that IFT, IDF or IDF, sorry, right? What is the full form? Just have a look at it. But this is the place where we put all these switches and servers, right? Now, the point here is we don't see any cables in this beautiful floor, right? But we can see here that we have a PC, we have a printer, and we have an access point. By the way, access point is something with which your laptop connect wirelessly, right? But as I mentioned, that access point is eventually connected to your switch over this wire. And believe me, these guys have done this cabling so well that you can't see these cables. Sometimes it is coming in from the roof to this network room, or sometimes it comes under the floor, but eventually it needs to connect to the network room. For example, means if you see, right, we all have lights, we have electrical connectivity at our home, but we do not see wires. Why? Because wires are inside the walls. Similarly, the networking cables, these guys have done tremendous job. You can't see any networking cable, but networking cable is all about all there, uh, uh, inside your floor, or basically it's coming on the roof. So whenever you see this diagram, just try to understand that this is exactly a room in the building, and all from everywhere somebody has pulled these wires which are going into this, right, access switches. As simple as that. If this picture is clear to you, believe me, many things are going to clear, right? Mostly we just run away from cabling. Try to understand. A true network engineer understand this cabling also, right? Having said that, let's move to the next board where we will be talking about wireless, right? So I have just taken out one access switch, right? Although we had three access switches, but I'm talking about only one access switch. This access switch is connected to a PC. There is no doubt about it. When we connect this PC, it is going to get the IP address from our shared services and it will start communicating. We have the printer. When we connect it, it is going to get another IP address. But what about this PC? What if I do not want to connect it with a wire to the switch and nobody connects, right? If I have my mobile phone also, nobody connect these things with the cable, right? And that is why we need wireless connectivity, and that is why we need wireless network. If that is the case, we have an access point. But eventually, this access point is connected to some port of the switch. As simple as that. And one more interesting thing is over this Ethernet wire, this switch can supply power also, and we call it power over Ethernet. What is the meaning of power over Ethernet? When we connect this switch and this access point, right? The switch will supply the power or current also over this wire so that this access point will start running, will start working. We do not need a power cable to connect the access point, although we can do that too, but that is the extra hassle we need it, right? In today's world, basically switches, or specifically Cisco switches, are capable enough of providing the power over this Ethernet. We call this technology as power over Ethernet. I think you all are aware of it. If no, that's perfectly fine. Once this access point is up and running, it is going to advertise the signals, the wireless signals, and this laptop can catch this wireless signal. Now the question arises that if this guy is a sales guy, how it is going to connect the sales VLAN? Because here it is very, very simple that if this PC belongs to a sales guy, then I can mark this port as sales port, or maybe VLAN number 10, whatever is the sales 10, right? Sales VLAN. But how on earth on this wireless I can assign this? Believe me, what I can do is I can give three different type of signals, which we call it SSIDs. One SSID is going to be for HR, one is going to be for engineering, the another one will be for sales. When I open my laptop, I will be seeing these three things, right? And if an engineer is there, he or she will be connecting to the engineering SSID. Really, really interesting. And here in this AP, I have explained that if it is an HR SSID, it should be connected to VLAN 10. If it is engineering, maybe VLAN number 20. If it is sales, then VLAN number 30. I have mapped this thing inside this access point. By the way, there are multiple ways to manage this access point. What Anjali is planning, Anjali is saying I will be putting or I will be placing one access point per floor. It means that I'm going to have only three access points, and to one access point, maybe 20 to 30 people can connect. As simple as that. Or maybe 15 to 20 people can connect based on your traffic. Now, interesting, right? So there are two types of APs. One which can be managed on their own, which we call standalone access point. But if we have a bigger network, enterprise network in which we have 200, 300 APs, then it is very, very difficult to manage these single APs. And we need a WLC, wireless LAN controller. Believe me, this wireless LAN controller, I have created a course which is available on my website. Have a look at it if you are more interested in WLC. But now the question arises, Mr. Vishnu, that is fine, that three SSIDs you have mapped them, but what kind of link will be this? Then I will be saying this link will be your trunk link. Why? Because trunk link has the capacity of taking traffic of multiple VLANs. So suppose this guy is connected to engineering and engineering has VLAN number 20. What is going to happen when the frame comes out of this port? This frame will be having the tag value 20. So when this reaches to switch will understand that this frame is actually for VLAN number 20. As simple as that. So simple, right? And this is how this standalone AP work. But believe me, in big enterprises where we have so many access points, we do all these things from a WLC, right? We cannot advertise, we don't advertise so many SSIDs. Believe me, we advertise only one SSID. And where exactly or what VLAN this guy should be getting, it is the responsibility of a different server altogether. So I'm not saying this is the only design. We are just trying to understand. We are just trying to build the network for a 50 to 100 people. But you can easily extend this network to 5,000 people also. You just need to have maybe WLC in case of wireless. If you want to see how wireless or WLC work, just have a look at my course on wireless networking, right? So I think on this board, we understood how wireless will come into picture. So eventually, how your network or the overall picture of your network looks like this, right? Right. So you see only this picture, right? This is the beautiful floor of a office. But eventually, you will see all the device in network room like this. We have distribution switches, we have servers attached to distribution switch. You can, some of you can say that, Mr. Vishnu, there are some servers which we need to put in demilitarized zone. Yes, those are the security concept, but just for the simplicity's sake, I am just placing some of the servers here, right? Maybe this server is a Sports India website server. We have access switches, we have trunk port, we have SPIs here also. Then we have access points connected to this switch, and then access point will be virtually connected to this laptop or maybe the mobile phone. We have wire devices, again access point, right? I think this is the overall picture of the network till yet. One more thing I would like to introduce here is that right now on the distribution switches, we have the gateway or the switched virtual interface for all different VLANs, right? You all know that. And this can lead to the single point of failure. Why? Because if you have the SVI is configured only on one distribution switch, then it's a problem. If this switch goes down, then my default gateway is down. And if my default gateway is down, I cannot go to different networks, because we all know that if I want to go to the different network, I need to go via gateway. And if the gateway is not there, I cannot go into the different network, right? Actually, your Sports India doesn't want that, and that is why you need gateway redundancy also. By the way, what is the meaning of redundancy? See, Sports India's requirement was that if one particular device goes down, you should have any other path to go, right? Otherwise, this is going to be single point of failure. If you put another switch here, then basically you are putting a redundant switch, which is providing you redundancy, right? An extra path. If you create SVIs only on one switch, it's a problem. For example, suppose for VLAN number 10, 192.168.10.1, this is the green SVI which you have created here. You should have created the same gateway here also 10.1. And if you think that why, how can I have the same IP address on the two switches, right? And that is where the gateway redundancy protocol works, which we call it first hop redundancy protocol, which is basically your um, HSRP or VRRP. So basically your design should include this. And all these things I have explained in my switching course. If you want to have a look, just have a look. As I mentioned, if you want to design a network, you should be solid with respect to fundamental concepts. And HSRP or first hop redundancy protocol is actually your foundations, your basic, a part of your foundation or basic. So this is the overall picture till yet, but you must be thinking, Mr. Vishnu, you haven't included the internet till yet. Where exactly the internet is? Can you just tell us about that too? So in the next diagram, I will be talking about how we are going to connect internet, because if we want to connect internet, it means that we are inviting people from outside, or we are going from our network to outside world, right? And outside world is full of good people as well as bad people. If that is the case, there are high chances that now, because your network is connected to internet, there are going to be chances of an attack on your network. And that is what I have done here is, although I have taken services of two different service provider. Number one is Airtel, number two is Jio. I am saying Airtel is going to be my primary service provider. If this goes down, then I will be having Jio, right? Why I would need two different service provider? Because Sports India Private Limited requirement was that there should not be any single point of failure. If I have taken services of only Airtel, what is going to happen if this Airtel is down? It's a problem, guys, right? That is why I have taken services of two things, right? Maybe Anjali has decided to have internet from two different service provider. One is Airtel, one is Jio. If Airtel is down, then I will be choosing my secondary one, which is my Jio, and I will be running this in active standby mode. Means Airtel is going to be my active, and if something happens to Airtel, I will be going to Jio. How I can configure these things? I can easily configure this thing, right? Although I can make it active also, but that is going to be design choice still. But let's start with the active standby. What I can do is I can track a any server, maybe Google server, from over this interface. If this interface or the Google server is reachable, then I would think that Airtel is up and running. Otherwise, it's down, and that is what we call as track. We can easily track a server over an interface. If the server is reachable, it means that Airtel is up and running. If the server is not reachable, then basically this track is going to inform me now the server is not reachable. Now it is the time to make sure that Geo is up. Very, very interesting, right? See again, how we are going to achieve this active and standby portion. It is just a configuration thing. Configuration, I would say, is really easy for that. No doubt about it. But try to understand the full picture. Why we have introduced two different service providers. Why we are talking about active standby, right? Maybe active can also work here very easily, but we need more configurations. If we talk about current scenarios, current solution like SD-WAN, SD-WAN does all these things automatically, although we have to define the policies for that too. Why firewall here? I have connected whatever is coming from Airtel or Jio, the connections into a firewall, right? This firewall is doing two different things. First thing first, we all know my current or the total network is built on private addressing. There must be somebody who is going to convert this private addressing to public addressing, right? And mostly the layer 3 switches, whatever we have, the switches here, as where we have created SVIs, they are incapable of doing that. Either we have to put a router or firewall. Firewall is capable of doing that, and we will be doing network address translation here. Means our private part of the network, when they go out and reach to internet, their source address is going to be changed with the public address, right? First thing first, this firewall is doing. But firewall purpose is to provide security also. We all know that. Suppose we have connected Sports India Private Limited website right here, although it should be connected to a demilitarized zone, DMZ, but I don't think we know that much in security. If you know, then you already have an idea that we have to connect it. But suppose we have connected the server of the Sports India website right here on the distribution switch, although it is not a good practice to connect the server which is reachable from internet into a distribution switches, we can connect definitely the DHCP or DNS here, because these DHCP and DNS can be accessible or are going to be accessed by these access switches or the devices which are connected to these access switches, right? But suppose we have connected a Sports India server right here. It means that we will be inviting somebody from outside or internet which is going to get access of Sports India, right? And this can be a legitimate user or maybe a hacker. So what this firewall does, this firewall by default it sends everything whatever is going from inside to outside by default, although you can create some policies also, security policies, right? But right now what is happening is it is not letting anybody to come from internet to towards your enterprise. Why? Because it believes that whoever is coming from outside to inside, I am not going to believe it until and unless somebody who knows firewall just open a port or punch the firewall so that people from outside can come inside, right? So this is Sports India. Maybe it's running HTTPS website, which is available on port number 44, 43. So what I'm going to do, I will be opening a 443 port so that people can come from outside and connect to 443 port of this server. As simple as that, right? Really interesting. So there are many traffic paths here. Now, if I talk about how these two guys, which are connected to different two switches, how these two guys are going to connect, let me draw the traffic path. Maybe they can go here and come here. How this computer can connect to internet, right? Maybe a Google server is right here. So let me draw another with the red color. Maybe it can go here via firewall, via Airtel, and this is the another traffic flow. As simple as that. Now, Sports India, another requirement was that what is going to be how these people who are sitting at their home, they can communicate to the people who are sitting in the enterprise. And now you are connecting a guy who is sitting at home to your enterprise over a medium which is highly unsecure, means we have internet which is not secure at all. So basically what you need to do for that, you need to build a secure connection from your home PC over the internet to this firewall. And by the way, we call this as virtual private network. So when this connection is private, right, or secure, now this guy, right, let me draw with maybe some other color, maybe say this color. This guy can travel over this blue tunnel and then come inside via firewall and can reach to this enterprise resources. As simple as that. So try to understand how many things we have discussed, right? We started with the access switches. We then have distribution switches. To connect access to distribution, we have trunks. right? We have spanning tree protocol to avoid the loops, because if three switches are connected like in a triangle form, or maybe the form the spine and leaf form which we have seen here, there is a loop which is avoided by spanning tree. Then we discussed about switch virtual interface. We talked about gateway. We talked about HSRP protocol, right? We talk about firewall. We talk about active and standby load balancing. We talked about virtual private network, right? We also call this as remote access VPN. Just try to understand. To build this small network, we need all these things. And do not forget about network address translation also, right? Now, the thing is, what exactly you are going to run between this firewall and your distribution switches, right? Because on the distribution switch, you will be having three different networks, one for HR, the other for security, and the last one is for your engineering department. Three different networks you are going to have. You can run a routing protocol between your firewall and distribution switch. This can be OSPF, or you can work via static routing also, because the network is really small. But now you must be thinking, Mr. Vishnu, you made one mistake, or Anjali, you made one mistake, and I would be wondering, what is that mistake? The mistake is, don't you think that right now we have a single point of failure in this network? Right? And Anjali is saying, yeah, I can see that the firewall is a single point of failure here, because if this firewall goes down, everything goes down. So Anjali did talk to Sports India guys here, right? And they said that, see, we do not have any budget of procuring two firewalls, but maybe after some time we will be taking one more firewall, then we can run active active or active passive design of the firewall, right? But for now, one firewall is enough. Although I am deviating from the customer's requirement, because the initial requirement was there should not be any single point of failure. But right now I can see there is a single point of failure, right? But if I do not include the firewall, the problem is that security is compromised. How I'm going to do the remote access connection of the VPN, right? Interesting. So sometimes I am not able to meet the requirement of the customer, right? Which I have corrected in the first meeting, but because of some constraint, because of the money constraint, or maybe in the real life, you will see a lot of constraint. Maybe some politics are there in customer environment, right? Maybe the money is not enough. Maybe they are planning to buy these firewalls later point of time. So I am not going to say that this design is bad, because anybody can come and point on this design that you haven't created a good design. The reason is that you have a single point of failure in this. But what we can do, right? Because I am not going to put, as an architect or as a designer, I am not going to put a firewall from my money, right? Because customer is not able to purchase one. That's why I have given this design. But as soon as they will be giving me one more firewall, I will be putting this firewall here and making it active active or active passive, or maybe any design, right? So again, try to understand. Anjali's response is, see, collect the requirement from the customer. In your case, basically you are giving this interview to somebody, right? And he's going to say, design your network. Do not jump on designing the network. Ask questions. Consider him as a customer. Then basically the scenario based question or the design question is actually how much is the test of how much you think, right? So ask as many questions from the interviewer. If interviewer say, no, no, I don't want to answer so many questions, then assume things. But whatever you are assuming or presuming, just let your interviewer know. For example, uh, see, the small network can be of 10 people also. The small network can be of 50 people also, right? But the design is going to be changed. The small network can be inside one room, or maybe within three different floors of the building. If there are 3 different floors, we need to put one switch on the one floor, right? Design gets totally changed. So whatever you are presuming or whatever you are thinking, right? Just tell the interviewer that I am presuming this thing, means my definition of small network is 50 people, right? What about your definition? Bring him on the table, ask as many as questions, otherwise there is going to be problem, right? So this question is actually my favorite because if somebody can explain all this thing together, see, I do not want to go and ask what exactly the SVI is. In this type of questions, basically you understand, we presume that you understand the basic concept, and that is why you are talking about this many things, right? Now I would say these technologies, or you can understand where these or where all these technologies can fit together, right? Last board I have is that if I go to the network room, then I will be seeing this kind of racks there, right? So as I mentioned that we will be having 3 access switches. So suppose this switch, and this is my access switches. So I have a rack there. I will be putting these switches into the rack, and maybe these 2 are my distribution switches. This is my firewall, right? And maybe leave about this device. This is what you see inside your network room. And you don't see a lot of cables coming because these guys have done cabling really, really well, right? So overall, this is what I wanted to explain you as a part of the network design. In next question, what I'm going to do is I will be creating this complete network, whatever I on EVNG or basically on packet tracer, and then I will be putting some faults in it. Then I will be showcasing how basically we will be troubleshoot the network. So see, from the starting 13 questions, we have strong fundamentals, concepts, right? 14th question is about designing the network. 15th question is about troubleshooting the network, right? I'm not saying that these 15 questions or 15 hours of study is going to change, right? Or it is going to give you everything with respect to computer networking. No, but if you are a network engineer having 1 or 2 years of experience coming out of the college, right, and giving a network interview, don't forget to go through them all 14 or 15 questions. Having said that, uh, thank you so much for being a wonderful audience. See you in the next question. Bye for now.